Good morning, this is your Stat Sensei, Mr. Spensei, and this is the first of the problems on the test review, two sample proportions, and this will be a confidence interval on lowering my A1C. This is the same one we went over in our warm-up identifying the important information. I'm still going to read it again. It says millions of Americans are pre-diabetic. That could be our population. Meaning their blood sugar levels are elevated, but not yet high enough for type 2 diabetes diagnosis. Health experts recommend lifestyle changes to lower A1C levels, a key measure of blood sugar control. To determine whether dietary changes or exercise is more effective, researchers conducted a 3-year randomized study on pre-diabetic adults. A research team at a major southeastern U.S. medical center recruited participants from both urban and rural areas. Individuals were randomly assigned. That's super important because the fact that they're randomly assigned is going to be part of our condition one, and it'll eliminate condition two. Diet groups: 490 individuals followed a low glycemic or low sugar diet. So this is our sample size for our diet group. So N for sample, D for diet. Low reducing blood followed a low glycemic diet, reducing processed sugars and carbohydrates. The exercise group, well, we have a sample size of 530, so that's N for 530, for E for exercise, committed to a moderate intensity diet for 150 minutes per week. At the end of the study, participants underwent testing to determine whether they had successfully lowered their levels to non-pre-diabetic range. Research results showed that 269 individuals in the diet group, so this is our X for our diet group, achieved this goal compared to 263, so X for our exercise group, so that we have that. We constructed 90% confidence interval. So we recorded this information. We said 269 out of the 490. We did this in a warm up, and we had 263 out of the 530. That was for the exercise group, also done in a warm up. And we noted that P hat is X over N. So 269 over 490 and 263 over 530. All right. So we already recorded that information. So there it is, copied down again. All right, this is our formula, and it says construct a 90% confidence interval. Well, this is my confidence interval formula, and if I look at it, it's like, hey, you know what? I already have, I already have P hat 1 right here. So that's taken care of. I also have P hat 2. So that's taken care of. And notice the P hat 1s show here and here as well. And we also have P hat 2 showing up. And I see that I have N1 and N2, so I'm good there. The only thing I'm needing is Z star. So we need to calculate Z star, and we want a 90%. So we're going to go second vars, inverse norm, 1 minus 0.90 divided by 2. Because it's a Z-score, we'll be working with a mean of 0 and a standard deviation of 1. And we want it to be to the left. And even though it's negative, we're positive people, so we're going to go ahead and make it positive. So we have inverse norm, 1 minus 0.90 divided by 2. This is our mean, and this is our standard deviation. And we're always going to be to the left, and like I said, we need to make it positive. Okay, at this point, we can go ahead and plug in our information because we already have P hat 1. Which we plugged in right here. P hat 2. This is P hat 1 again and P hat 1 again. P hat 2. Then we plugged in our sample sizes. This is N1 right here. And this right here is N2. So the only thing we didn't have is Z star, but we calculated Z star right up here. So there's our Z star value. All right. Now, as far as drawing it, well, when you're working with a confidence interval, you're going to be centered on P hat. So in this case, we have two P hats, so we're going to be centered on their difference. So let's go ahead and take our calculator real quickly and take 0.5489 minus 0.4962, and we get 0.0527, and that's what we're centered on, P hat 1 minus P hat 2. And we have a 90% interval, so this area right here is 90%. And of course, we want to calculate our lower bound and our upper bound. So we need to go ahead and write our parameters. And since we have two proportions, we'll have two parameters. And let P, oh, you know what? We're going to go ahead and run the test. Excuse me. So running the test, stat test, two proportion Z interval. All right. Well, at this point, we're going to have 269, 490, because 269 out of the 490 lower their A1C. In this group, 263 out of 530. 90%, 90 divided by 100. And we end up getting 0.00134 and 0.10417. All right. Notice this is positive, and we had diet minus exercise, which means diet must have been greater. All right. Diet had to be greater in order to have a positive value. The name came straight off the calculator. I'm going to go back real quickly so you can see it. Stat test, two proportion Z test. All right. And I just pulled it off straight off the name. So our parameters, let P1 equal the true population proportion of participants on a low glycemic diet. That's another word for saying sugar, just so you know. You don't need to write the word sugar, but that's what it is. All right. And let P2 equal the true population proportions who um, on a low glycemic diet who lowered their A1C, who participated in moderate exercise, who lowered their A1C, because it's really important to note that these are not just the ones who were on the diet, but they're also the ones who lowered their A1C. Okay. So conditions, random assignment. All right. So, and that was let's go back to our scenario. It says randomly assigned. So they randomly assigned the sample size of 490. And here we had a random assignment of 530, which means we have two independent random samples. That takes care of our first group. Because we have random assignment, we don't have to multiply times 10. So we don't have this condition. We don't have to do it because we're multiplying by 10. The next thing, when you're running a confidence interval, you're going to use P hat 1 and P hat 2. When you're running a hypothesis test, you use P hat C. So what was our P hat 1? Well, P hat 1 was 5489, and our sample size is 490. So this right here is just P hat 1 and its associated sample size. So 490 times 0.5489, and we get 268, which is greater than 10, and that's we always compare to 10. Then we have 490 parentheses 1 minus 0.5489, and that's 221, and that's also greater than 10. So we're good to go on both of these. It's large enough. We need to check the other to make sure it's large enough to use the normal approximation. So once again, we have P at 2 is 0.4962. And so this is what we're listing right here. So our sample size, which is 530 for the second group. So we're going to go 530 times 0.4962 is 262, and that's definitely larger. And we also have 530 parenthesis 1 minus 0.4962. And that's 267, and that is also large enough. So both are large enough. So we're good to run the test. All right, both samples large enough. Okay, okay to use the normal. So our conclusion, well, what was our interval? 0.00134. Don't forget about that because we're going to say it. So we are 90% confident the true population proportion difference between participants on low glycemic, and I'm going to go ahead and write the phrase who, and participants on a, I add it here, low glycemic diet and participants who participate in a moderate exercise who lowered their A1C. Got to have that. Need to add that. I would add it right at the end of exercise in this case to make it easy. So we're 90% confident the true population proportion difference between participants on a low glycemic and participants who participate in a moderate exercise who lowered their A1C lies within the interval 0.00134 and 0.10417. Please remember, we calculated that up there. That's just a restatement of that, right? Always make sure you have really good parameters. Once again, this begins the statement of our parameters. Super important that you have that. And I highly recommend putting the lower A1C in there because it's not just the groups, it's the ones who lowered their A1C. All right, I appreciate you watching. Look forward to seeing you on the next one. Thank you.